Welcome to this presentation on the 7 deadly sins of dyadic data analyses. These slides come courtesy of David A. Kenny, who is one of the leading researchers and scientists in structural equation modeling, and particularly in dyadic data analyses. His book on dyadic data analyses is a very important one, and if you end up doing a lot of dyadic analyses, I highly recommend you get it, as it goes into much more depth into how to conduct dyadic analyses properly. So before we get into the 7 deadly sins, a little caveat here. Most of these sins described here in this presentation are common in traditional multivariate analyses. However, doing proper or using proper dyadic tools such as structural equation modeling and M+, most of these sins you can take care of or manage in your analyses. So you'll see these in traditional and older journals that do not do dyadic analyses, and we want to make sure that we don't replicate the past errors and shortcomings of analyses that have been done previously, but rather use the proper tools and take the proper steps to make sure that our analyses are much more rigorous and also have fewer biases. Now that we have these tools, we need to avoid these outdated practices. One last caveat is that while some of these are considered sins or weaknesses and drawbacks and introduce a lot of bias if you do not do these, some of these are okay if there's proper justification, and what I mean by that is empirical justification, so that there's been proper preliminary analyses done to show that this would not be a problem in the analysis. However, most commonly, this is not done in journals in the past, in journal articles in the past. So now for the 7 deadly sins. The first sin is assuming that dyadic members are distinguishable without testing whether such an assumption is warranted. Like I talked about in our last module, it is very important to do a test of distinguishability to determine whether a dyad is distinguishable. If you do that test, as we talked about, and as I have shown you in other videos in this module, you do not need to worry about committing this sin because you've taken care of it. So the most common and problematic case is where there are separate analyses for men and women in opposite sex dyads. Now sometimes researchers do that because they do not have matching data. They do not have matching partner data in order to do that. Other times they do have that matching data, and rather than doing a dyadic analysis, they just do separate analyses for men and women. It's much more appropriate to do a dyadic analysis and make sure that you test for distinguishability. The second sin is assuming that a statistically significant effect for one member of the dyad, but not significant for the other, implies that the effect is different and significantly different between the members of the dyad. For example, if you have a path coefficient of 0.3, that shows to be significant at less than p, than 0.05 for p. And then for women, you see a path of 0.1 for that same path, that you would assume that, well, it's different. That for men, it's stronger and therefore significantly different. You cannot make that assumption. We do not know whether they are significantly different unless you have done a constraint test. And I have shown you how to do that in the examples I've given in this lecture as well. So if you want to know whether an effect is different between two members of a dyad, a corresponding path, you need to do a constraint test and do that chi-square difference test to determine whether it is actually significantly different one from the other, no matter how different they may appear to be. The third sin is summing or averaging the scores for two members of the dyad without any empirical justification. This is something that has been common in past research where they didn't have the tools or the know-how to do a dyadic analysis, so they just took the dyad and summed or averaged their scores together and then did an analysis of the couple score rather than doing dyadic analyses of the dyad separately. So it can be acceptable to do that if the actor effects are equal to the partner effects. If you have done the preliminary analyses to show that, then you can sum them together because they are non-distinguishable dyads. However, if they are distinguishable, and if the actor effects do not are not equal to the partner effects, it is inappropriate to sum or average the scores of two members of a dyad together for an analysis. The fourth sin is using discrepancy scores as a predictor without controlling for the main effects. This is kind of similar to that last one, but rather than summing the scores together, they take the difference of the two scores and then use that in their analyses. This is, again, inappropriate to do unless the actor and partner effects are equal, and it's specifically for discrepancy score, they're equal and opposite to each other. However, with dyadic analyses tools, you don't need to worry about this because you can just do a dyadic analysis and test for distinguishability and do it correctly. The fifth sin is assuming that one member causes the other without realizing that the other has influence. So this is a big word here, but pseudo-unilaterality. There we go. So what this is doing is essentially when you're having a predictor be a parent score and the outcome be a child score, and assuming that without doing a dyadic analysis. You have to assume that that effects are bidirectional, that parent impacts child just as child impacts parent. Doing a dyadic analysis allows you to account for that and actually evaluate that bidirectionality through the actor-partner interdependence model. The sixth sin is not including partner characteristics as predictors. So in other words, conducting analysis without partner paths. Researchers sometimes try to get out of testing partner paths by saying that their theory does not make predictions about partner effects, and so they exclude them from their analyses. However, if the dyad is interdependent, conducting analyses without partner effects could lead to really biased estimates and effects, and you are essentially getting wrong information. So if the dyad is interdependent, you should test your model with partner effects. If you find that the partner effects have no impact, then you can drop them, and then your theory that does not include anything about partner effects could be accurate. Less commonly, you may also see this with actor effects, where they only look at partner effects and ignore actor effects. So when you're doing tests between dyads, ignoring actor effects or ignoring partner effects and just relying on it saying, well, my theory doesn't make any predictions about that, is really introducing a lot of biased estimates into your theory and into your subsequent analyses. The last sin number 7, is treating the individual as the unit of analysis and ignoring the dyad. And this has a lot to do with what I talked about with non-independence in the sample, that half of our sample is independent on the other half, and so therefore the dyad should really be used as the unit of analysis rather than the individual. If you can show that each member of the dyad is truly independent on the outcome variable, then you can evaluate the individual for the unit of analysis. But that tends to be extremely rare in social science research because dyads tend to be very dependent and interdependent upon each other. So in conclusion, while I focused a lot on the sins and poor data analyses, I've tried to also kind of show you what you need to do instead so that you don't fall into these. And again, some of these practices can be acceptable if proper preliminary analyses are conducted. And I tried to explain within each of these sins what kind of analyses, preliminary analyses would have to be conducted, what they would need to show for that to be okay. For more information, get that Dyadic Data Analyses book by Kenny, Kashi, and Cook. Chapter 15 deals a lot with these issues, but the book in general is a fantastic one to get to really get a deeper dive and have a stronger resource and reference book for doing dyadic analyses.